Good morning. My name is Khadija Khaled, and I'm going to take you through the AI term paper. So let me share my screen. Yes, so we are dealing with text summarization through machine learning through natural language processing. So a brief introduction about this is that the amount of information on the internet has grown a lot in the recent years, and so we need to find ways of processing all this information to make it meaningful to people. Then through this, we have background for natural language processing, where it has become just more popular in the recent years because of increasing popularity of online data, because people do a lot of research and all that. So we need to find ways of processing all this data so that it can be very helpful to these people. So in our literature review, we used supervised learning and unsupervised learning techniques. Then in the supervised learning, where we use data, training data, because we have like the model generates a summary, and then there's a human summary that it compares it with so that it can learn to become more accurate. And then unsupervised learning, it's the opposite, where there is no other data, so the model just generates summaries and just keeps learning from those given summaries. Then some of the research gaps is like lack of human-like understanding, and then data-driven nature, cause mostly in supervised learning, because the models rely a lot on the data, and so it reduces the quality. Just reduce the quality of the performance of these models. Then lack of interpretability, where we have like the black box models that are difficult to interpret and understand. Then we have a summary of our paper contributions. We develop an interpretable and explainable model, as we shall see. Then we use the large high quality training data set, as we shall see, the BBC new summary data set. And then we explore some of the new advanced learning machine learning algorithms. Then a brief description of our data set is that it has news articles. We're using the BBC news summary data set. It has articles of news from 2004 to 2005 in different categories: entertainment, sport. So it has all these articles, and then it has corresponding summaries for these articles. Then in our exploratory data analysis, we cleaned this data. First of all, we read the data from the summary data from the BBC news data set. Then we clean this data. How? Then we use through the algo processing techniques, where we convert it first of all to lowercase. That's one, so that we can easier deal with all the text, because we are using sentence. We're going to use tokenization, as you'll see. So we convert it to lowercase, then remove any punctuations, then remove the stop words. Stop words are words that don't have any a lot of meaning, like is, are, words used to combine sentences, he, him, all that stuff. Remove all that. So we developed all these pie charts and box plots. So the pie chart shows the distribution of how large each of the classes is. So this shows you that each of our classes has the same number of articles, right? So it's evenly distributed, as you can see. But then the lengths, as you can see from the box plot, the lengths of these articles is different, right? Yeah. So in our model selection, these are part of the models we use, but we generated, our final work is based on the NLKT, this upper model here, as you see it. So let's talk about the GenSim model first, because I'll explain this NLKT later. Then GenSim model uses modern statistical machine learning. It uses text rank algorithm, right? So we have also the Pegasus model. The Pegasus model here, it is a Google model actually. Yeah. So it uses abstractive data summarization. It uses the encoder decoder kind of architecture. So it uses the encoder, the input text, encodes it, and then converts it to a context vector, which is a numerical representation of the data, and then decodes this context vector into a summary. Then we have the SPACY model, which is an NLKT, kind of similar to NLKT, but for it uses it's more object-oriented. Then we have the GLAV model, which uses vectors. We represent words using vectors. It puts them in a vector space where it groups similar words together. Yeah. Then in conclusion, this is this AI summarization, text summarization has the potential to greatly impact the efficiency of, and accuracy of information in various aspects, because people need to generate the most important text and then summarize it and then use that, because there's a lot of research, of course, that we do recently. We do a lot of research, a lot of reading. So we need to find ways of generating the most important information from all that information that we find online. Yeah. And then in the future, of course, we shall develop this and explore more of the abstractive techniques. But in this case, we're using extractive technique. So these are the links to the data set and the Python source code on Kaggle. Yeah, and then those are the references. So let me just explain the the code quickly. Yes. So yes, so this is it. Here, so yes. So here, first of all, we import the NLKT library and then download the stopwords, the punkt. Then we give this text as our input. This is just a summary, an article from the news dataset, just for demonstration purposes. So we give this to define this text here. So here we get a stopwords and then put them in a list, right? So stopwords equals set stopwords dot words, then English. Then we print these stopwords. Here we have, as you can see, why, he, is, above, from. All these are stopwords that are not going to carry any meaning in our final summary. Then we use words is equal to words dot tokenize. This is an inbuilt function in the NLKT library in the text. So here we are giving us the words, tokenize the words in the text. So what this will do, it will split all these words into a list, right? So it splits all the words into text. The text here is our variable text that we declared here, this variable, this text. So it splits all these words into a list, separate them, of course. Even the punctuation will separate, as you can see. So then we declare a frequency table in a dictionary. So we loop through the word, for word in words, we loop through the text that we have. Then we convert them to lowercase, as you can see this line. Then if word is in stopwords, right? If word in stopwords, continue, so ignore that word. But if word is in frequency table, otherwise, so if the word is not a stopword, right? Then just add the frequency, and just add 1 to the frequency, right? Then we print this frequency table, as you can see the dictionary here, Jare, 3 times, joins 1, fairy tale 1. So we loop through all that, and then we count the number of times each word appears, then we put it in the dictionary. Yes. So sentences, now we are splitting the word into the text into sentences using the sent tokenize function. And we give our input as the text, our variable. So yeah, we can split the words. What this will do is split the words. Every time it finds a full stop, it's going to split that into a different sentence. So as you can see here, sentence, as you can see here, Denmark up to this point here, the different sentence, right? So we have tokenized now the sentences. Now, here we're getting the sentence value. We are adding up all the frequencies in the words, right? In the words in the sentences, each word and each frequency, that we can get the value of that sentence, as you can see here. So we are going to add up all these and we print this value. So as you can see here, Jerry, this first sentence, 54. So we have added all the frequencies of the words in this sentence, and it has given us 54, right? In this next value, next function, we are getting the average of all these, right? So, sorry, we are getting the average of all this, and then we are getting it as 43 here. What this average will do is that in our final summary, as you can see, we loop through the sentences, right? And then because each sentence has the sentence value. So we loop through this sentence value, uh, dictionary, and then we generate whether the value is above 1.1 times this average value here that we have gotten. This is the importance metric. Okay, if I should say, yeah. So we declare our variable summary as an empty string. Then every time we find a sentence that has a value greater than this, that fits this, we add it. We leave a space, right? Then we add that sentence. Then here we have printed the summary, and that's it. So thank you for joining me. Have a blessed day.